Oh, I'm so glad we locked eyes from across the room here at the crowded poster session of the 2022 Human Sense Pressing Conference hosted by the beautiful University of California, Santa Cruz. I bet you're just dying to know how we can quantify performance constraints on case alignment typology using information theory. Well, you're in luck. My name's Stephen. Let's take a gander at my poster. I'll start with a bird's eye view of this project. So I'm using conditional entropy to quantify the information theoretic burdens that case systems place on language production and comprehension. I've calculated the entropy values for a sample of naturalistic and simulated case alignment grammars that are all ultimately interpolated from Georgian corpus data. I found that the attested case patterns are simpler than we would expect from totally random systems, and it looks like production constrains case typology more than comprehension does. So very generally put, conditional entropy measures the unpredictability of one variable given a known value for some other variable. So it's calculated according to these formulas. If you're interested in the math behind it, I actually have another YouTube video on this channel that breaks that down. But I think it'll be more useful to start by imagining a pro-drop scrambling verb final language that inflects its core syntactic arguments for case. Think about how hard it would be in general, abstractly, to inflect the clause initial noun phrase for case when speaking this language. And conversely, when listening, how hard would it be in general to parse the intended syntactic role of that clause initial noun phrase? So I propose that we can quantify the difficulties associated with these tasks according to these two conditional entropy values, which I'm labeling the production burden, H of K for case given R for syntactic role, and the comprehension, H of R given K. I'm connecting these two complexity metrics to the low conditional entropy conjecture, which posits a complexity ceiling on acquirable grammars. The core insight here is that, say, inflectional paradigms can only be so irregular before the most entropic forms of those paradigms, the forms of a word that are hardest to predict, are regularized during language transmission. My research questions are, to what extent syntagmatic patterns like case alignment, in contrast to inflectional paradigmatic patterns, exhibit similarly constrained conditional entropy. And I'm also curious if we can find any ways in which H of K given R, so production burden, and H of R given K, comprehension burden, shape morphosyntactic typology of case. A little bit of background now. So morphosyntactic alignment refers to the way in which morphological categories are associated with different syntactic positions. If you've taken a typology class, you might be familiar with a diagram like this. Classic question being, how does the case marking, symbolized alpha, beta, gamma, of intransitive subjects, S's, does that pattern with the case marking of transitive subjects, A's, or with direct objects, P's? In a nominative accusative language, all subjects, A's and S's, pattern the same way. They get case alpha, which we would probably call nominative case, in comparison to direct objects, which get case beta, accusative case. That's not the only way to slice things up, of course. There are also ergative absolutive languages where intransitive subjects and direct objects pattern alike, and a handful of tripartite languages where each of these three syntactic roles gets its own case morpheme. You know, but this table 4 here is really just an idealization. Most languages are more complicated than this, and there are some languages like Georgian that have like really spectacularly complicated case alignment systems. What makes Georgian so complicated is that we need 7 distinct syntactic roles to describe what's going on, 4 types of subjects symbolized A, Z, S, and E, 2 types of direct objects, P's and T's, and then also indirect objects. Moreover, there's a 3-way split such that those 7 syntactic roles are assigned different case categories in different grammatical environments, specifically in different tenses. So in one set of tenses, we get this pattern using just the alpha and beta cases. In another set of environments, another set of tenses, we also throw in the gamma case, and so on and so on. So the details aren't important to dwell upon here. I just want to point out that already we can kind of see how the linkage between morphology and syntax is sort of uneven across the different case categories in Georgian. This gamma case is specific to a particular set of tenses and just two types of arguments, but the alphas and the betas are a lot more entropic, are a lot harder to link to a specific position and environment. So just how complicated is this case alignment system in an information theoretic sense? Well, to answer that question, we'll need to know the relative frequency of each pairwise combination of the three cases in Georgian and the 7 syntactic roles. I queried the Georgian National Corpus data and got these raw counts of every micro role in each of the tense environments. And from there, it's pretty easy to calculate how frequent, all of the transitive subjects in case gamma, or all of the experiencer subjects in case alpha, so on and so on. These allow us to calculate the key conditional entropy values that we'll be thinking about. Conditional entropy here is measured in bits, where 1 bit is the amount of uncertainty associated with the choice between 2 equally likely outcomes. So looking at these 4 values here, calculated over the macro roles, so whether just we're thinking about subjects, direct objects, indirect objects, and not something more granular. Both comprehension and production, those values are hovering around 1 bit, which means it's about as easy to either predict the intended macro role of an inflected noun, or to inflect a noun for the right case given an intended syntactic micro role. It's about as hard to do both of those things as it is to predict a coin toss. The micro role values, on the other hand, are a little different. The comprehension value, comprehension burden is higher, and I think that makes sense because there are just so many more micro roles than there are macro roles. Is kind of just a measure of the granularity of the columns, really. And then I think it makes sense that this value, the production burden, given a intended micro role, so whether we're dealing with an unaccusative subject or a thematic direct object, that's not as challenging as thinking about the macro role. Because if we look back at this table, there are a lot of micro roles that are always inflected the same way. Like it's S column, those are all inflected in the alpha case. The G's, the indirect objects, are all in the beta case, and so on. Now, how do we contextualize these findings for Georgian? Well, what I did was keep these corpus data constant, but remap how each of these cells is associated with a particular case category, according to other logically possible, some of which were tested case line patterns. So I did this remapping for 17 attested alignment systems, similar to the case patterns of these languages listed here. This one in particular is something similar to Icelandic's case system, where this alpha case is associated with most types of subjects, the gamma case is associated with direct objects, and then a third case, beta, sort of dative, is associated with indirect objects and experiencers. You'll notice that in this language, not only are the cases distributed in a pretty neat way with a lot of overlap, there's no split. So in all 3 of these environments, the 7 macro roles are assigned case in an identical way. That contrasts with the about 10,000 totally randomized case alignment systems, like this one here, this kind of really wacky checkerboard of our 3 case values, just randomly distributed across this case alignment paradigm. This is, as far as I know, an unattested type of case alignment system, but nevertheless logically possible. So with this typology of alignment patterns in tow, I calculated the same 4 values for each of them, and I plot the results here in figure 1. So let me just try to dissect what's going on here. You'll see the values for Georgian plotted in the dark black dot. The languages of the naturalistic sample are the diamonds, and then the languages which were randomly generated are the clouds, which are which the violet plots represent too. I'll point out that the color is important here. So the gold values correspond to unsplit languages, like this kind of Icelandic-y one, and the gray ones are split, you know, like this totally random split, and then also some of the other tested split languages besides Georgian. Running Welch's independent samples t-test, we find that the attested patterns are all less entropic than the simulated ones, except for the non-split production entropy values. So this golden plot here and here. I want to wrap things up by talking about a question in a domain you might call theoretical typology. So how do two specific grammatical parameters, number of cases in a language and the number of splits, how do those factors contribute to complexity of a case system, independent of, you know, ergativity, accusativity, and so on? What inspired me to think about this question is that, you know, in my own typological investigation, it seems like languages tend to have about 3 case categories to mark core arguments: subjects, direct objects, and indirect objects. And you know, alignment splits are uncommon, and splits more complicated than a two-way splits are really uncommon. So I was wondering if these patterns that we see in the typology of case are coincidental, or if they might be in some way connected to comprehension and production burdens. And to explore that question, I ran 16 more simulations, generating 5,000 alignment systems, varying the numbers of cases and splits that they feature. So between 2 and 5 case categories that were unsplit, like that Icelandic language we looked at earlier, or having a 2-way, 3-way, or 4-way split. The results for the conditional entropy values are here in figure 2. One thing that really jumps out right away are, you know, all these crossing bars here. And I think it's pretty intuitive why this is the case. So, you know, we look at all the circles correspond to the comprehension burden measures. And here we see that predicting the correct micro role of a noun phrase given knowledge of its case is always harder than predicting the macro role. And, you know, that makes sense. There's just more micro roles than macro roles to choose from. On the other hand, if we need to conjure the right case inflection, it's easier to do so when we have a specific micro role in mind than it is a more general macro role, because of the way, you know, when we pool the columns together into the macro roles, that combines together potentially disparate columns. So that, I think, is intuitive. What's a little more insightful is the fact that, you know, as we increase in cases, case alignment systems are easier to comprehend. And I think, you know, even if we just look at this simple case of a tripartite language versus a nominative, accusative, or ergative absolutive language, this makes intuitive sense, because, you know, in a tripartite language, if we encounter a noun phrase in the beta case, we can be certain it's not merely any kind of subject, but an intransitive subject. So, you know, the more cases an alignment system has, the easier it'll be to comprehend. On the other hand, you know, as we increase the number of splits, unsurprisingly, these systems become harder and harder to both to use, to comprehend, and to produce. A few words to conclude. So start generally by contrasting the standard classical approach to case typology, as sort of a descriptive taxonomical one, enumerating the ergative languages and accusative languages and describing the types of alignment splits that exist and what conditions them. I'm finding in this line of research that information theory gives us a more explanatory window into case, and not merely thinking about the types of case alignment patterns that exist, but starting to understand why some types of alignment systems are more common than others. In the future, I'll be using sentence processing theories like the P-chain model to help better explain these theoretical complexity ceilings. The core idea here being that more entropic grammars will be harder to use, making the acquisition channel noisier. Also review the tentative conclusions from my simulation. So first we see that attested alignment patterns are less entropic than totally random ones. You know, that's not super surprising because you know, how could a totally random case pattern like this come to be? We should always be thinking about the diachronic pathways for any type of grammatical phenomena when searching for sorts of acquisitional properties. And but I think a few more interesting conclusions too. So first, we're starting to see that case is more streamlined for production than it is for comprehension, especially when calculated over the syntactic microcode. So that's clearest in figure 1, where you know, these calculated values for the production burden are clearly much lower than the values calculated for the comprehension burden. So you know, these seem to be there seems to be a lower ceiling on production than comprehension for case. Moreover, as languages have more and more cases, there's some trade-offs between different types of language use, the production and comprehension. And of course, you know, adding more splits makes everything harder. Also kind of interesting is the fact that, you know, these 2 case languages seem to be pretty rare. And maybe one reason that is because they're considerably harder to comprehend. So maybe one pressure from comprehension on languages is to, you know, bump up a system from just 2 cases that distinguish all 7 possible grammatical roles up to another one to, you know, flag the like indirect objects to say. And then finally, you know, there are some obvious limitations to this approach. It's a really very abstract way of thinking about case. You know, I began by having you think about, you know, the very first noun phrase in a clause out of the blue, thinking about how to inflect it for case or how to predict its grammatical role given knowledge of its case. You know, that's not a very realistic way of thinking about either production or comprehension, because there's so many highly correlated grammatical cues that help both, like, you know, word order and animacy. Other information theoretic research has looked into some of those, and I, you know, look forward to extending some of these findings there too. But I will point out that, you know, there is maybe a little bit of a hint that there's at least when it comes to word order, something interesting going on here, because, you know, if you look at these diamonds that are the highest in my sample, those corresponded to the verb initial languages in my sample, Cebuano and Chamorro. So a sort of tantalizing observation here is it could be that verb initiality facilitates more entropic case alignment systems than verb finality. So I'll wrap things up here. I would be, you know, really happy to get any feedback or questions either through my email or the HSP conference portal. Take care.